Okay, problem 12.1.18-E. Tough problem. Well, the last parts of it anyway. Let's look at it. Use a one-way ANOVA to conduct a hypothesis test of the equality of three or more populations means. Okay, so first of all, the null is always equals. The alternative is always that at least one of them is different from the others. So it doesn't tell us which one's different. We have to do some further evaluation if we want to find that out. But anyway, let's find the test statistic. So they give us the outcome. Or do they? No, that's the Bonferroni result. So first of all, notice there's 5 data points for each of the 4 means. So we put the data into StatCrunch. He says. Second try always works. And we go to stat ANOVA 2-way. Okay. Oh, not 2-way. My bad. Stat ANOVA 1-way. And we're going to select all of the columns. And I think that's all we have to do. Yep, we just compute. Okay. So the test statistic is down here, the ANOVA table at the bottom. So the test statistic rounded is 7.37. Straightforward. And the p-value for the ANOVA is 0.0025. They run at 3 decimal places, so it's 0.003. Okay. So the significance level is 10%. So we're certainly less than 10%. We're at 2.5%, 3%. Well, actually 0.3%. We're less than 1%, put it that way. So we are going to reject. There is sufficient evidence to warrant rejection of the claim that the 4 different treatments yield the same popular weight. And that's obviously not, we can't support that they're all equal. In fact, if you look at that's the other thing, you want to look at the means. You can see that the means, the last one is more than double all of them. In fact, it's 4 times as big as the third one. So they're obviously not equal. The fourth one's obviously much larger. So according to the Bonferroni results, if we look at these results, if you look at, they call it significance here instead of p-value in the last column on the Bonferroni results. So with the first two say there is no significance between the no treatment and the fertilizer group, so it's not significant. Same with the second one, between treatment 1 and 3, the no treatment and irrigation, there is not. But however, there is a significant difference between the no treatment and the fourth one, which is fertilizer and irrigation. So that we can tell that. Okay. But now you have to read this real carefully, because it says use the Bonferroni test procedure with the 10% significance level to test for a significant difference between the mean amount of the irrigation treatment group, which is number 3, and the group treated with both fertilizer and irrigation, which is treatment 4. So identify the test statistic and the p-value. So the test statistic, which you can find on page 577 of the textbook. So let's do that. Should open up pretty close. Yeah, 568. So we want page 577. And there it is. But see, it says X1 bar, X2 bar. That's the generic. We're going to do X3 bar and X4 bar. Okay, so first I'm going to open up the calculator. So I've written that formula down. You should write that formula down on the side. And now we got to go back to our printout to get those two, to get what we need. So open up the calculator. So in the numerator, we're going to have, let's see, it said between the third and the fourth. So X3 bar is 0.42. X4 bar is 1.606. Okay, there's the numerator. Oop, I got to get a decimal point in there. All right. It's all divided by the square root. So second square root. Now, 1 over n1 is 1/5 because they're both 5 for the n's. So it's 1/5 plus 1/5. So I'm just going to write 2/5, which is 0.4. 1/5 plus 1/5 times the MS error. MS error is right here, 0.17583. And so I think I got everything I need. So this will give us the test statistic. Now it could be the opposite. It could be plus 4.47 if we subtract the other way, because the numerator is what sets the sign. So 2 decimal places would be minus 4.47. Okay, that was perfect. Good job. Now, it's minus 4.47. That's a t-statistic. Now they want the p-value. So what I got to do is put this test statistic on the t-axis and see what's the area to the left in the left tail. So to do that, I have to open up StatCrunch. Let's do it this way. Let's open up StatCrunch directly. Again, we'll just leave the other one to go because we may have to go back there. But I go to calculator t-stat, and I want it to X to be less than the number I don't know. Well, first of all, the degrees of freedom. Now the degrees of freedom are for the whole test. There's 20 minus 4 because there's 4 columns. So there's 16 is the degrees of freedom. You add up 5 plus 5 plus 5. There's 20. But there's 4 categories, so 20 minus 4 is 16. That's how we do it. And then here I put in the test statistic, negative 4.47, and it tells me the p-value is 0.0000. So it's essentially 0. Okay, now, that's a tough question. If that comes up on a test, I probably will be much more lenient. So what do the results indicate? Reject. There's sufficient evidence to warrant rejection of the claim that there is sufficient evidence. So it's C. I almost missed I looked at D. It says that's insufficient evidence, so it's C. Okay, that's a tough question, but if you study it, all the answers are available. Okay, so where am I? Dr. K out.